Let us start with the third question now. Let G be equal to set of all rational numbers except rational number 1. So this is the set G now, and the operation that I'm going to use on G is A star B. I'm going to write it as A plus B minus AB, where A and B are in G. Now this G with this particular operation forms a group. What we want to do in this exercise is that we want to tell what is the identity of this group. Second, if alpha is some element in G, we want to find its inverse. So let us solve this exercise now. Now, if E is identity, then what will happen? Then A star identity will be equal to A again. Therefore, A plus E minus AB will be equal to A. This step comes because of this formula of A star B. Now we can simply cancel this A and A because A is a rational number which is not 1. So remember, A is not equal to 1. I'm sorry, I should have written here A, E. Let me go to the next page. So after cancelling A, I will get E minus AE is equal to 0. Therefore, E into 1 minus A is equal to 0. But A is not equal to 1. Therefore, 1 minus A cannot be equal to 0. So we divide both sides by 1 minus A. So that I will get E is 0. So the identity of this group G is equal to 0. Let us go for the second part. Let alpha belong to the set G. We want to find its inverse. We want to find what is alpha inverse. In some textbooks, alpha inverse is denoted by alpha dash. So let us call alpha inverse equal to beta for simplicity, which we want to find. Now, alpha belongs to G means alpha belongs to Q minus 1, means alpha is a rational number which is not equal to 1. So let me write alpha is in Q, but alpha is not equal to 1. If alpha inverse is beta, this means that alpha multiplied by beta must give you identity. But we know in the previous sheet we have seen that the identity is 0. So this means that alpha star beta, which is equal to alpha plus beta minus alpha beta, is equal to identity is 0. This means that we want to find beta. So this means I will keep beta alone, and I will write beta into 1 minus beta into 1 minus alpha is equal to minus alpha. So this means that beta is equal to minus alpha upon 1 minus alpha. Obviously alpha is not equal to 1, therefore 1 minus alpha is not equal to 0. So we could divide it easily. So this is the value of beta, where beta was nothing but inverse of the element alpha. So we conclude that given alpha belonging to G, its inverse, which is alpha dash or alpha inverse, is given by minus alpha upon 1 minus alpha, which we had called beta. So this is the inverse of the given element alpha in G. So this finishes our exercise. The next exercise that we have is that, let me go to the next exercise. The next exercise we have is that we have to write two groups of order 4. Writing two groups of order 4 is a very easy task. The first and the simplest group is Z4, which contains 0 bar, 1 bar, 2 bar and 3 bar. This is a group with respect to the operation addition modulo 4. So this is the first simple group of order, a group of order 4, which is a very simple example. The second one is, let us take an example, G equal to set of all numbers of the which are 1, minus 1, I and minus I. This G is a group with 4 elements with respect to the operation multiplication, usual complex multiplication. It is an easy exercise, you can do it. The third example of a group with 4 elements is the Klein's 4 group. This group is also denoted by V4.